Rockets are amazing machines. They are marvels of engineering and technology designed to overcome the immense challenges of space travel. They carry things to space, from scientific instruments to satellites and even humans. But how do rockets work? Let's break it down step by step to understand the complexity behind these powerful machines. First, rockets have a propellant. It's like rocket fuel, but it's much more than just that. Propellant has two parts: fuel and an oxidizer. The fuel is what burns, and the oxidizer is what makes the fuel burn efficiently. The fuel burns, and the oxidizer helps it burn really well. Next, there's the engine, which is the heart of the rocket. The engine burns the propellant. This makes superhot gas, which is crucial for generating the necessary thrust. This gas shoots out of the back of the rocket at high speed, propelling the rocket forward. On top of the rocket is the payload. This is the part of the rocket that carries the mission's objective. The payload is like the passenger. It can be anything from scientific equipment to humans. It can be a satellite, a telescope, or even astronauts. Each payload has a specific purpose and mission. Finally, rockets need guidance systems. These systems are essential for navigation and control. These are like the rocket's brain. They process data and make real-time adjustments. They make sure the rocket goes in the right direction, ensuring it reaches its intended destination safely and accurately. To understand how rockets fly, we need to dive into some fundamental physics. And who better to start with than Isaac Newton, the father of classical mechanics? Newton was a brilliant scientist who lived in the 17th century. His work laid the foundation for much of modern physics. One of his most famous contributions is Newton's third law of motion. He stated, "For every action, there is an equal and opposite reaction." This principle is crucial for understanding how things move. Let's take a simple example: a balloon. When you let air out of a balloon, the balloon flies around the room, right? This is a perfect demonstration of Newton's third law. The air rushing out of the balloon is the action force, and the balloon moving in the opposite direction is the reaction force. Rockets operate on the same principle but on a much larger scale. The hot gases shooting out of the rocket engine create the action force, and the rocket moving upwards is the reaction force. This push, known as thrust, is what propels the rocket into space, overcoming Earth's gravity. But wait, Earth has gravity. Gravity pulls everything down. This force is what keeps us grounded, making sure we don't float away into space. It's the same force that makes an apple fall from a tree and hit the ground. But what if we want to leave Earth and explore the vast universe beyond? How do we escape this powerful pull? How do rockets overcome gravity? It's all about thrust. Thrust is the force that propels the rocket upwards, counteracting the downward pull of gravity. The engines burn fuel to create this powerful force. If the rocket's thrust is stronger than gravity's pull, the rocket goes up. This is why rockets need incredibly powerful engines to break free from Earth's gravitational grip. Getting to space is hard. It requires precise calculations, immense power, and sometimes, even a bit of luck. Many rockets have failed before finally succeeding. Rockets use stages to help. Each stage has its own engines and fuel, designed to work at different parts of the journey. Imagine a rocket like a 3-story building. Each story, or stage, has a specific role in getting the rocket to space. Each story is a stage. The first stage is the foundation, providing the initial thrust needed to lift off. The first stage has the biggest engines. These engines generate the most thrust to overcome Earth's gravity. It gets the rocket off the ground. This is the most critical phase, as the rocket must break free from the strong gravitational pull. When it runs out of fuel, it falls away. This reduces the weight of the rocket, making it easier for the next stage to continue the journey. Then, the second stage takes over. It ignites its engines and continues to push the rocket higher into the atmosphere. It pushes the rocket even higher. This stage is crucial for gaining the necessary speed and altitude to reach space. It also falls away when it's empty. By shedding the empty stage, the rocket becomes lighter and more efficient. Finally, the third stage carries the payload the rest of the way to space. This stage ensures that the satellite or spacecraft reaches its intended orbit, completing the mission. There are different types of rocket engines, each designed for specific missions. Some use chemical reactions to make thrust, providing powerful bursts. These are the most common. Others use ions. Ions are tiny particles that can be accelerated. Ion engines don't make as much thrust as chemical ones, but they can run for a long time, making them efficient. They're good for long missions, especially in deep space. Scientists are even working on nuclear rockets. These rockets would use the power of atoms to make thrust, potentially revolutionizing space travel. They could be very powerful. Rockets are complicated machines with intricate designs, but with a little science we can all understand the magic that lets us explore the universe and beyond.